So my name is Jurriaan Hage. I'm an assistant professor at Utrecht University, and I'm going to talk about making domain-specific language a practical reality. And actually, I just happened to see that that was the name I gave to the abstract. When I prepared my talk, it was actually like that, domain-specific type error diagnosis in Haskell. But I still remember then that actually when I wrote the abstract, it was originally the second title. But then my PhD student and I decided, well, this doesn't sound spicy enough, so we turned it into the first one. But I will actually talk about the second one instead. Of course, what I will talk about is a part of making domain-specific languages a practical reality. Although, well, yeah, Haskell, practical, not really. So what's the purpose of my talk? I want to introduce you the field of type error diagnosis in a somewhat sketchy way. And then I want to address one way of solving the problem of type error diagnosis. And I didn't ask this question to the previous speaker for nothing. Usually when people talk about, yeah, complicated type systems, and then I go, yeah, complicated error messages. So, and that gives me work to do, so that's nice. So the way that I solve this is by allowing the type inference process to be modified from outside the compiler. So the compiler needs to be able to support that, but then you can kind of get an external DSL for writing down type rules that behave differently for your specific DSL and also give error messages that use terms from that domain. Yeah, so that's the idea. And I applied this idea to achieve domain-specific type error diagnosis for embedded domain-specific languages in Haskell. Yeah, so is that practical? Well, it's on the way to practical. But what I also want to do by doing this is to show you what is actually possible, not just in Haskell, but in any strongly typed language. I haven't done that. I may not even do it, but I also hope that other people think, well, this is a nice idea. We need to have this in Scala. This is a nice idea. We even need to have that in Java. Or they say, well, maybe we should actually impose a type system on our dynamically typed language just to have this. Yeah? That's the kind of thing I'm hoping for. All right. So, to start from scratch, we're talking about statically typed language. The compiler type checks your program to see if there's nothing that can go wrong. This is the well-known slogan, well-typed programs can't go wrong. And this is done by what I call an intrinsic type system to distinguish it from, like, say, type and effect systems and non-standard type systems that I also work on. But the idea is that there are some programs that are parse correct and scope correct, but they're still type incorrect because you manipulate values in the wrong way, and that's where you get the slogan. And of course, it's always for the right definition of wrong. Yeah, because exceptions can also occur in Haskell. You can still have a crashing program. I like to crash my Haskell programs once in a while just to show them. So yeah, it's not all pleasant in Haskell, not even in Haskell, even if the type errors were right. I mean, programs can still go wrong. But everybody, I think, probably has played with a language like this. You kind of have the feeling, okay, this is the kind of errors I can typically find. And our previous speaker actually introduced lots of things that you can check with a type system that you probably had not thought you could actually do. Yeah? Now, then if a compiler refuses to compile and run my program, or an interpreter refuses to run my program, I think I deserve an explanation. That's me. I mean, if I get a paper rejected at a conference, I also expect arguments from the reviewers. Yeah? And not just it sucks, or you get a 0. I expect arguments. Why is it wrong? Why is it bad? What did I do to offend you? So this leads, in my case, to the need for diagnosis. So what's type error diagnosis? Well, simply put, it's the problem of communicating to the programmer that and or why a program is not type correct. And depending on the situation that you're in, you might at least expect to know that it is type correct or incorrect. It could also be that it says what kind of inconsistency did it find. Yeah, is there an incompatibility between values, or is a type class instance missing? All kinds of errors can occur. What you would also typically like to know, where did you find this mistake? Is it in this function, or is it in that function, or is it everywhere, like what you typically have with what you can have with type classes? Another thing, what would be really nice sometimes, is maybe you can also suggest how I can fix the problem. If I call a function that expects an int and a list of int, and I reverse the arguments, can't it just tell me that I should reverse the arguments? Now, if you look at the literature, turns out functional languages probably have had a lot more problems with bad error diagnosis because there's actually quite a bit of research in that field. Not much, but much more if you compare it to the industrially much larger field of OO language. So let's look at a bit of Haskell. Not very complicated Haskell, I hope for you, but certainly Haskell. So I want to check whether access is a palindrome, which means that the reverse of the list is equal to that list. And I've implemented the reverse in some way. And yeah, quick Haskellers will probably say, no, this is not type correct. And indeed, the program is not type correct. This is the error message you get. You get an occurs check that we cannot construct the infinite type that T is equal to a matrix of T's. And this is very hard to satisfy once you start doing that. And then it says expected actual type, and then it explains you why this is. Actually, it says the problem is here. Turns out, actually, the problem is here. This is type correct, but it's not the type that you expect of reverse. All right. So let's look at a bit more in detail. So first of all, it doesn't say where really the error occurs, because it says something about reverse access equals access, but actually the problem, if we know, for our interpretation of reverse and palindrome, you would actually find out that this implementation is incorrect. Although it's type correct, it's still incorrect, but it only shows up when you use it later. It's pretty intimidating. Infinite types. I've never heard, before I started to work in Utrecht, I'd never heard of an infinite type before. Occurs check. I hadn't studied Prolog either, so how would I know what an occurs check is? Yes? So what you see, it's intimidating. Another thing is it's mechanical in the sense that it kind of reveals the underlying type inference process to the programmer, who should probably not be aware of this. Generally, it's not very helpful, and actually the likely fix is very simple. It's one letter. Fold R should be fold L. And then it's okay. Yeah, so. Nice. Now, there were 3 people in Edinburgh, Young, Trinder, and Wells. They wrote down in one of their papers a good error reporting manifesto. I like to refer to that because it kind of gives you an idea. Okay, not a lot of people do type error diagnosis. People who started, they just started. Maybe it's a good idea to kind of make sure for yourself, okay, what am I aiming for in these? Well, it should be correct detection and correct reporting. Okay, that's so strange. You want to be precise, so the smallest possible location, not somewhere in the program, but in this definition. You want to be succinct, don't mention any stuff that's irrelevant. It should not depend on the implementation, so we want it to be amechanical. It should be source-based, so desugaring is actually out of the question. Or you have to have some mechanism for translating it back, which is, I think, much harder than simply not desugaring in the first place. Most of the compilers, especially when we actually started to do this for the first time, were very biased because they use Hindley-Milner's, Damas-Milner's implementation that kind of traverses the program and just performs unification or equality tests on the fly between types. But that also means it's very dependent on the order in which you make your mistake. So in this case, I take the head of a list. But the problem here is that the list can only contain either booleans or characters, not both at the same time. But you can tell, well, there are many characters, there's only one boolean. But if you try this in most compilers, it will complain that 1 is not a boolean. And then you change that into a boolean, say, but 2 is also not a boolean. And 3, and 4, and 5, and so on. All right, so this kind of bias, and of course, if you say, well, I'll change my order to go always from the back to the front, then I can change the list around to get the same problem. Yeah, so there's no fighting bias. There's always an example that really screws things up. It should also be comprehensive. You should not leave information away that is necessary for explaining everything. So these, I think, are always wise striving for. Sometimes you will focus on the one, sometimes you will focus on the other. But in the end, quality is extremely subjective. It depends on the intentions of the programmer. Yeah? The reason why I said the mistake is here is only because I say this is reverse and that's palindrome. I could come up with different names here, and you would think the mistake is here. Why would you do that by comparing blob of x's with x's for particular definitions of blob, right? And of course, a compiler will not look at your identifier. He's probably reversing again with his palindromes, right? That's not the kind of thing that your compiler can come up with. So, I was like, Yes. Yeah, well, yeah. We'll have compilers that can only compile programs that compute palindromes. That would be nice. We have a lot of time on our hands. All right, so it depends on these factors. It also depends on programming experience. It depends on your background. Are you a PHP programmer that's trying his hand at Haskell? Or are you an Agda programmer? Or a Curry programmer trying his hand at Haskell? Yeah, you can get them from higher up and deeper down. And all of these people will tend to make certain kinds of mistakes because they still have this PHP feel or whatever in their fingers. So is type error diagnosis a doomed enterprise? Yeah, if everything is subjective? Well, I don't think so. But first of all, there's a lot to learn. There's also a lot to be careful about. But I'm going to explain to you what we did in 2003 already. So quite a bit of time ago. So actually we implemented domain-specific type error diagnosis. We didn't call it like that because nobody talked about domain-specific languages. I only did it when I wrote a new proposal 3 years ago. Then everybody was talking about domain-specific languages. And as it happens, it is about domain-specific languages. So at that time we made a compiler called the Helium compiler, which was meant to be used by students when they started to learn how to program. It is a subset of Haskell, Haskell 98, minus type class definitions and instance definitions. It does have type classes, but they're all built in. And it does have instances, but they're all derived. Yeah, so you have your num and your show and your eq class and your ort class, but you cannot add your own stuff unless you build it into the compiler. Now you can play with it. It's recently I put it on the Hage, so you can play with it if you really want to. It has a constraint-based approach with many heuristics, multiple solvers, but most importantly, it supports this domain-specific type error diagnosis. I'm going to explain to you how we do that. Not how we do it, but what it looks like when you use it. So it's about domain-specific type error diagnosis. So let's look at the definition of Walid Taha for domain-specific languages. You have a domain which is central, notation is clear, informal meaning is clear, and the formal meaning is clear and implemented, to which I like to add, domain abstraction should not leak. For example, in embedded reports. So embedded domain-specific language, I'm still zooming in to that very tiny part of the world when I can actually start to solve problems. So embedded languages, internal if you are like Marty Fowler, they are achieved by encoding the DSL syntax inside that of a host general purpose language. And according to Paul Hudak, that's the ultimate abstraction. So there are quite a few advantages compared to usual DSLs. You can say, and these are arguable because people will argue against the fact that these actually are not advantages but disadvantages. But, so you might be able to use the familiarity of the host language because maybe you just want to optimize people implementing stuff in a general purpose language by providing them with EDSLs to do their work quicker. This is not going to be useful to you if you want to, for example, use DSLs or for non-programmers, like SQL. That might be different. It gives you an escape hatch in case you forgot something, or in case, for example, you would like to use the floating point that somebody else implemented and you don't want to implement all over again for your own DSL. I can imagine that. So you can also use existing libraries, compilers, IDEs. You can more easily combine DSLs, because usually the assumption is I work in one DSL, SQL. And they say, oh, wait a minute, I also want to have some other stuff like machine learning stuff in there. Oh, how do I combine it if all of these are separate tools, separate compilers? It's much more easy to do if it's just a matter of importing libraries and hiding a few things, renaming a few things. But even if you don't agree with all of this, I think it's still useful for prototyping DSLs because building a DSL with an IDE is a big investment. And here you can play around trying to find the right vocabulary, the right fluency for your DSL. So there's still two challenges, at least in Haskell and I think also the other languages. Domain-specific optimizations and domain-specific type error diagnosis. Optimization and the other are also complicated and hard to do in the non-EDSL setting, but there you have more control because you're basically building a complete new compiler, complete new environment. And today I'll talk about how we can do something about this domain-specific error diagnosis, getting this control for error diagnosis inside Haskell, in a Haskell compiler. So to do that, I need to introduce an EDSL just for the fun of it. So I usually take parser combinators as an example. Basically what it means is an executable form of eBNF and extensible as well. So everybody, I assume, knows about context-free productions. And this is a non-terminal C, D, and E, and we have small tokens A and B, so these are terminals. And you can translate that to a parser combinator implementation where you say, well, the parser combinator C is just a Haskell function that first runs the parser D, followed by the parser E, or it parses the token A, or it parses the token B. That's what it says. I hope to It's just that for juxtaposition we have to use star because function juxtaposition is already used by Haskell for just making function calls. And here we just take a slight variant of that symbol there. So essentially non-terminals become Haskell functions. You can add semantics with the dollar. This just applies a function to the result of a parse, for example. There's lots of other combinators that are defined, but also nicely, it's just a library. You can add your own. Yeah, so these are things like sequential composition. So first parse C and then first D and then E, but throw the result of E away. And this is throw the result of the first parser away. And these are things like 0 or 1 time. This is star. This is plus in EBNF jargon. But they don't really matter. The thing is that you have such a library, and what you would like to do. At first, let's first see the bottom in its full glory. So here I write a parser for expressions, which is either a expression at the end priorities level or it's a lambda. So how do I parse a lambda? Well, it starts with a slash. Then I have a list of identifiers, which I parse with this p folder 1. Then there's the arrow, and then there's the body of the lambda. The sem_explum actually expects 2 arguments, the list of identifiers and the parse of the body. It doesn't care that you actually read this particular symbol there, and actually I should have omitted this larger than, and then everything would have been correct. But now I get this error message. Why? Because the underlying implementation, the encoding of parser combinators inside Haskell is revealed to the programmer, who of course should have no understanding of this whatsoever. So it looks large, it's complicated. You have to actually match up the types yourself to say where actually is the mistake. It takes a long time. It doesn't mention parsers anywhere. And as it happens, it's actually very easy to fix. It's just one larger than sign. So what we do in the Helium compiler, we brought the type inference mechanism under our own control, explicitly generating constraints instead of solving things on the fly, so that we could manipulate the set of constraints. And then we provide hooks to the programmer for describing the way in which the type inference process behaves for certain classes of expressions. Not for all expressions in Haskell, but only for those, in our case, that have to do with parsers, for example. Now, what is very important is to be able to guarantee that by doing that, you don't change the type system, you don't subvert it. So that was the thing that we also needed to do, and we can, it's very easy. So how do you organize this in a Haskell setting? Well, basically, if you build a module.abc with the Haskell extension, you can also supply, and typically the DSL designer will supply a file called abc.type that contains certain directives. I'll explain in a minute what they look like. And the idea is that whenever you compile abc.hs, it will load in this abc.type. It will store information also in the generated code for this abc.hs. So whenever you import abc.high file somewhere else, the bytecode file somewhere, you give the generated code to somebody else, he also still profits from your type error diagnosis improvements. Improvements. All right, and the compiler will do all of that for you. It will just rip out these rules and apply them for you to make error diagnosis better. Very nice. Of course, better, it's up to the library designer. Yeah, maybe they will also apply these techniques, and they have a nice servant.type file. They say, well, for every expression that deals with any of our combinators, you get an error message, dipshit. Or read the manual, page 78, dipshit. Yeah, so it's just up to the programmer, the library designer, to decide what do I want to communicate to my end users. You can also think about, I mean, this of course is not very realistic because they like their clients, they like to keep them. But I'm a teacher of functional programming. And maybe in the first 2 weeks when people start to program, I want to say, well, whenever you make a mistake that involves map or folder, I just point them to the page in the lecture notes. First read over there and then come complain to me. Yeah? And maybe after 3 or 4 weeks, I will change that back to what it actually is. Yeah? But the thing is, I'm in control. Feels great. All right, so let's look at one of these specialized type rules, now still in a, let's say, deduction style format, but we'll go to ASCII art later on. So this is one of our parser combinators, it's the dollar. What does the dollar do? Remember, the dollar takes a function and takes a parser that generates A values, and then applies that function to the result of the parse. So it becomes actually a parser that produces B values. All right. So you can actually write a specialized type rule for this in this way, where you say, oh, so if I have this dollar, then the first expression is a function from A to B. The second sub-expression is a parser as A, and then the resultant type is parser as B. And X and Y are not necessarily variables. They can be any expression with that type. So this is our starting point. And I'm going to work that around to the specialized type rule. So what I first do is I rip out the specific types, and I replace them with placeholders like tau1, tau2, and tau3, and I make explicit on the side what constraints are there for tau1, tau2, and tau3. So this is clearly, I hope, equivalent. Just took them out, just a matter of notation. But I'm going to do a bit more. I'm also going to separate some of these constraints, because implicitly, by enforcing this constraint and that constraint, I'm also implicitly enforcing that these simple types, the things that they parse from, are the same. So actually, I'm going to make the set of constraints minimal, in the sense that I have as many as possible, and each of them only contributes a very small thing to the correctness of this expression. But in the end, it's still equivalent. And now, I write it down in an ASCII file, like this. So this is exactly what you would write in our specialized type rules. This says, for every expression of $, I have these meta variables x and y that can represent any expression. I introduce names for the types that they should have, and these are the restrictions on those names in that particular order. That will be checked by the compiler. And if I did it correctly, these are actually the constraints that would be checked by the compiler if I didn't write this rule. The difference, however, is that I can associate with every constraint a special error message. And now you see that, hey, when this fails, or that one fails, it actually mentions parsers. So that's simple. There is, however, something you can also, I know that it will check these from top to bottom. That means that when I check the fact that these are the correct symbol types, I can talk about parsers because I know that these two have succeeded. It's never the risk that actually when the person programming goes back and he says, he's complaining about the symbol types, but these are not even parsers, which might happen if I would check these things too soon. Yeah, so I can use that information. Of course, then you get error messages like this, which is a great improvement on GHC. Now, of course, we're missing lots of stuff, and those are what we call error message attributes. Things like the position of this whole expression in the program. So we can write that by interpolation, expert.pos. Expert.pp over there, that's the pretty printed version of the expression. Expert.tp would be, for example, the type. You can also interpolate the types that at that point have been found for T1, T2, and T3. All this information is available. And then you can write it like this, and then this is the error message that you get. So now you see it's at 2.21. The right operand of dollar over there, the string hello world, should not be a string, because it should be a parser string. You can also, when you don't like to write all these constraints with all the error messages here, you can also interpolate some of the constraints back in, and then you get the usual error messages for that particular constraint. You get still the ones that you write here, you get them explicitly. So for example, if you don't care about the fact that T3 is something of parser kind, that you say result type is not a parser, then you can just interpolate it over here, and the compiler will check it for you, but you get the usual error message. And you have a bit more control, but let's skip that for now. All right, there's another... If
you go back to your
yes.
error messages.
Yes.
The example of the error messages, not running it, but going there. So your last one is parser has an incorrect result type, which you give when B1 is not equal to B2.
Yeah.
But that suggests the error is in B2. How do you know it's not in B1?
It could be, but this is just what I decided.
To give a possibly misleading error message.
Yes. Yes. But of course, if you actually...
This is a good technique.
but I'm pretty sure you can write really good errors, at least type errors here, type error messages.
Well, to be accurate, what I would do is I'd say, well, I have these two things and they're
Ah,
supposed to be the same,
all right.
and they're not, which is what the compiler already does. So.
Yes, yeah. So you're correct, and of course, it's all up to me to write that in here. Yeah? In here, I can explicitly say, okay, I have this type and I have that type. I'm not saying there that one of them is not correct or anything. I just say, with this type, and they're not consistent. But it's up to me. Maybe the effort is worth it, maybe the effort is not worth it, but of course it is something you have to take care of, right? Yeah, but I think this is a crucial thing that there is, so also when we submit papers, they often say, but you don't show us that you can improve type errors, but we only give a mechanism for somebody to tailor the error messages to either improve them or make them worse because he likes the old versions of GHC much better. I don't know. But yeah, but it's possible. The thing is that if I want to write a, let's say, unbiased, yeah, because actually you've correctly seen actually that this is biased. Yeah, it says, oh, this is inconsistent with that, so that's to blame. So yes, I hope that in a real implementation I would never give this error message. But I would go for a more biased error message where I say, this is not consistent with that, and maybe I can explain a bit more, or how they can fix it, and so forth. Yeah, that's a good question. So the final facility I'd like to discuss is siblings, but it's pretty simple. So you could write it like this in the same type in the same type directives file. So basically what happens here is that, well, let's assume that you are a PHP programmer and you move to Haskell and you constantly make this mistake that you write dot for string concatenation instead of plus plus. Well, then you can train it by writing this for the compiler to check, okay, if there is something like concatenation going on, but you use a dot, replace the dot by the plus plus, oh, is it now type correct? Ah, then we give a suggested fix. And this is very easy to add. And you can also change it depending on the group of students you work with, whatever you like. It's all from the outside. You don't have to delve into the internals of the compiler, because that would be a no-no. But so this is the situation in 2003. So this was domain-specific type error diagnosis in 2003. A few years ago, I thought, after doing some type and effect systems, it's time to raise this idea from the dead again, but now do it for Haskell 2010. So I wrote a proposal to scale this whole thing to Haskell 2010, so that it actually works when you have GADTs and type families and blah, blah, blah. And I have a student working on that since 2013. So, isn't Haskell 19.8 complicated enough? Well, we've just learned that no, not by a long shot. We need flexible instances, multi-parameter, blah, 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 blah. If you look at the top 20 of downloads of Hage packages, 10 of them use flexible instances, 9 of them use multi-parameter type classes, and the list goes on. And this was already a few years ago. It's probably much worse nowadays. And people use GADTs, they use type families, they use functional dependencies, existential quantification, scope type value. None of these are supported by Helium. None. We're not even Haskell 98. So, I tried to sell this in a proposal as a project, and then one of the reviewers said, this is going to revolutionize programming. So I got the money. But I think that's it. So what have we accomplished since then? Well, we've worked on having conditionals in type rules, regular tree expression, and if you want to play with it, and now's the time to type in this URL since you have your laptop on anyway, you can play with it at this website. We've done a few more things, but this is what I want to talk about a little bit. So, why do we have map and fmap? Yeah, so map is the usual list traverser, and fmap is the one that is in the functor class. Well, part there's tradition. Map was there before functor was there. But you might also say, well, why not get rid of this map guy and just use fmap all over the place? Well, one, I think, is part of error diagnosis. If a student comes to me and starts to learn about functional programming, they apply map to lists. And yeah, in lecture number 8, I talk about fmap after type classes and stuff, but not in the first 2 or 3 lectures. But I do expect them to use map already at that time. Yeah, so, and then he makes a mistake with this functorial fmap, and then he gets something like functor, blah, instance, blah. So I guess this is why you can keep map around. So we introduce conditional matching in type rules to make sure that you don't have to keep it around. You can just have tailored error messages for map in case the type class instance happens to be a list. You can also have something similar, for example, that you can introduce monad comprehensions back into Haskell, because you can tailor the error messages for list comprehensions in Haskell with these rules. Now, there's much more to it, so we have a whole paper about this, but there's much more to it, I can't do that. But the idea is that if you can decide before an error is discovered that fmap is working on lists, then a special rule will kick in and tailor the error message for lists and talk about lists. The second one we've looked at is regular tree expressions. So you can write, and maybe I did not give this idea directly, but you can write arbitrary, almost arbitrary complex expressions on which to pattern match for which you want to improve. So this only improves the error messages if we apply map first to it and then some list x's, where map and it are library functions that have been defined. And I could also make it more complicated, but that's about it. Here I have two meta variables x and y with some single operator in between. What you cannot do is write lambdas here. What you cannot do is write lets over there. Yeah, but any application, even though it can be nested, I can also have here an expression that applies a particular function to x's, for example. It's all fine. It's going to work out fine. But this is all you can do. And my PhD student came up with an idea that, so this is pretty simple, but he said, well, I would like to have some kind of repetition and choice to be able to add to my patterns. And actually we came up with regular tree expressions that, actually we use regular tree expressions that somebody else came up with, and I'll explain a little bit what that looks like. There is already a disadvantage. So when I use helium, I get a complete and sound check for my specialized type rules. Here, I have to resort to something like quick check. And turns out Haskell reviewers at the Haskell Symposium really don't like if the type system is checked by quick check. They really don't like it. Yeah, so yeah. This is not my own computer, the other one burned down. So, but let's look at an example, why this would be nice to have. So let's think about the GEDT. We have x per a's, where we have a plus and a mult, and we have literals. And the literals have to come from the num class. So basically, these are arithmetic expressions where you have literals, for example, integers, or floats, and you can build expressions with plus and multiplication. Now, the idea is that when you have a literal of, like, let's say, a float in your tree, then all the other literals also have to be floats. And if there's an int, all of them have to be int. But the problem is, in all these unification-based type error diagnosis systems, they all go through your expression, and they will do it in a particular order, which introduces bias. So my PhD student said, well, if I have a function like execute that evaluates the expert and returns the result of evaluating this expression, yeah, if I know something about this expert A, I would like to be able to verify, for example, first, that all the leaves are checked correctly typed. So the lits are correctly typed. I can give them a type, because it could be that there's a function there, or it's a function that cannot be typed, or any expression cannot be typed. But once I know that all my leaves are well typed, I can verify that they all have the same type, A for A, so the same instance for A. And then I will verify that this A is actually in the num class. And then I answer for it. Of course, you might say, well, I prefer actually to check first that all of the things in the tree are in the num class, and then check that they're all the same. Yeah, be my guest. You just change the two rules around in your specification. This is not a specification. It's a bit too complicated for now to explain. But you can do that. You can modify it to whatever you want it to be. We only give the syntax for writing down these rules. And like I said, if you want to play with this, these things are on the web. So, I have introduced the problem of type error diagnosis. I've introduced some specialized type rules to achieve domain-specific type error diagnosis, and informed you about some recent developments. And of course, there's lots of ongoing work. So first of all, we're looking at lightweight approaches so that we can actually already get some of this in GHC without changing GHC too much. Another thing we're working on is integrating impredicativity in higher rank types into outside Enix as implemented in GHC. Because one of the things that is necessary for this to work is that the type inference process is constraint-based and it's one constraint solver. While in GHC, it's a bidirectional type system followed by a constraint sum. Oh, so outside in X is the constraint-based formulation of the Haskell type system as it is almost currently implemented in GHC. Yeah, good question. And we're also doing cosmetic changes to syntax because the rules don't really look very nice. And then there's future work. So we did find that writing down these rules is not easy. There's a lot of syntax going on, and we already have good ideas, I think, on how to make this by making this interactive. To make it much more easy for non-type system specialists to be able to define these kinds of rules. We'd like to then experiment with library developers and users and move to dependently typed languages like Idris and Agda, because that's where the real improvements, I think, can be made. Because, yeah. All right, and spread the gospel, of course, further to any language that is interested. Scala, maybe, I don't know. So I think that's it, and I'll leave you with the credits of people that have contributed to all of this work, and I thank you.
So you have a hypothesis which sounds really plausible, which is that if you allow the user, the embedded domain-specific language designer, to say what type messages they want, that this will be easier for users. That sounds very plausible. And you gave an example, but now we need to validate it. And you gave an example in your talk. You said, look, here's something you might write down, and it gives you this horrible error message which is hard to decipher. Where was the bit of the talk where you said, here are the rules we give, and with these rules it gives you this much nicer error message? And don't just say, well, we could do it. Right?
Oh,
you want some evidence that it actually works in practice, especially
so,
the talk
so
with practical in the title.
You mean this one?
Yeah.
Yeah. So actually, you can. Actually, I deleted it because I deleted the slides I had on siblings because I had too many slides. But this is actually something that is solved by the siblings.
Mm-hmm.
Yeah? Because the only thing that needs to change is that this guy is replaced by / less than star.
Mm-hmm.
And then it's correct. So if you would, actually in the Helium compiler, if you have that sibling, it will then, yes, might be risky. So I had another presentation from which I took these. And probably I deleted it over there, but let's see if I still have the old presentation around. So some of these I took from the talk I gave at Chalmers. And now let's see. This is a bit more elaborate and a bit more technical. I had a bit more time there as well. So, and of course, I mean, the only thing is that I think it explains well what's going on. It doesn't mean that it's a particularly good error message because in the end, it all depends on how much effort do you put into. Yeah, so actually, here's the other way around. Here I omitted this one. And it actually suggests that you put it back. But
right.
That's...
Okay. Good.
So Helium does this for you.
Right, and I expect you to do some experiments with sitting users down and you ask them how satisfied you are and,
no,
and you give them GHC and Helium and... Right? we need empirical work.
Oh yes, and we will. But the thing with Helium was that, so we built all of that and then the lecturer of that course decided not to use it anymore. I'm not that lecturer. And now I am the lecturer of that course. But the thing with Helium, is that, I've 5 programming assignments in my course. You can only do the first 2 at the most. The other thing you cannot do because you have to define your own type class, you have to define your own monads, you have to use the gloss library, and then I have to demand that my programmers switch during the course from using Helium to the other. And that's too much hassle.
Count the number of complaints. Count the number of complaints.
It's actually, a nice anecdote maybe is the following. So, of course, GHC doesn't have domain-specific type error diagnosis. It will shortly because we're working very hard on this. But, so I was at the Haskell Implements meeting last year, and I was also working on the lecture notes for my course. And actually, the lecture notes mentioned, this is the Helium error message, this is the very bad GHC error message. I hadn't written that, not my fault. And I was running through these examples again. It turns out that GHC simply gives exactly, or isomorphically, the error message that helium gives. So, I mean, and actually Simon was in the room, and I said, I think Simon has been influenced by some other compiler, maybe helium. And he was like nodding like this. So yeah, I think he, so I think for him, helium was a wake-up call at the time to not, I mean, if they can do it better than I can, then I have to improve it at least as good as they are. But of course, he doesn't have the domain-specific type error diagnosis yet. But actually, yeah, we sort of agreed that it's going to be part of this
This
project.
is really nice work. Please do the empirical work.
Oh yes, yeah, but that was the experiments at the end, surely. And I've actually, I did one experiment where I had students writing these things. So these were at that time undergraduate level students writing DSL type rules, and they found that to be pretty hard. So one thing I did not mention is that when you start to write down these rules, for example, there you want to have some kind of uniformity of your type error diagnosis. That it, for example, contrasts something indented 4 characters, blah blah blah. So we need some abstractions there to make it reusable. That you have a template in which you fill in information, you change the template, stuff like that. So the usability is really something that I want to pay attention to, and yeah, verify, like I said. Sure. Maybe we should go back to my presentation, the real one.
Are these enhanced type error messages, do you think they might be useful for Haskellers or only for students learning Haskell?
Oh,
or
no,
people using
I think
that
that
don't
if
come from Haskell?
so the question is this for what group of Haskell users is this useful? Is it for every user of Haskell, or is it just students, for example? So I think the people implementing the servant library, I think they would really like to have this kind of facilities, because other people are using their DSL, and they may not then come to complain, okay, there's something really strange going on, I don't understand this error message. If we can explain it better, if you can talk about, because they do lots of stuff at the type level. And with our conditional rules, for example, we can pattern match on that. You could say you can give different error messages. And this is kind of like the vision I have. When your list contains JSON, your type level list contains JSON or it doesn't. These kinds of things are then possible. So actually I think it's much more useful for the professional programmer than it is for the student programmer. Because we are working now on those things that students don't really need to know about yet. When they come to our course in advanced functional programming, then you're taught type level programming. Then you learned about monad transformers and all that stuff and GDTs, but in the first course that I teach, we don't go further than monads type classes, that's all. So there's less useful. And for that, yeah. Is that okay? I will go to you. No, you first. It's okay, you first.
So how do you see this extending to languages such as Scala or Idris or Agda that aren't in the sort of broad Hindley-Milner tradition where it makes sense to collect a giant bag of constraints and then try to solve them at the end?
So recently I had to look at the type system of Scala, and there's a lot to explain about it, that's for sure.
But the basic thing they use is some sort of a bidirectional approach, right?
Yeah, but also, I mean, they're already, I think, teaching your programmers about the subtyping relationship and the bidirectional combined with the colors. That's seeing that Java, for example, gets all these new features. They will get the same problems that Haskell has had, all the functional languages have had, and much worse because the way they put it into the language is much less elegant and less orthogonal. So it's a much harder time they will have to explain. And actually I have 3 papers about this, Java genetics, explaining Java genetics, not the domain-specific type diagnosis, but just using heuristics. And that's nice, but yeah, nobody picks that up. I'm back in Haskell, so for some reason it seems that people in the O world either say they don't care, or I know Odersky cares, but yeah, then you still, and there is some effort, but then again, not accepting. Yeah, you had a question. The one with the green. Yeah.
Well, it was pretty much the same question, but
Okay.
I'm interested whether, I mean, you mentioned maybe you could do the same in dynamic languages, but that would mean just rewriting the runtime
No,
errors.
this is
that
fun.
would be
That's-
super interesting.
I was screwing with you.
Okay.
Of course, nobody's going to do that. But actually, I had a slide about this. Of course, I mean, also people writing in dynamic language, they find out that you can't really build dependable big systems in them. And then you go from PHP to Hage. And once you let the type system in, there goes my H-index. Right.
You mentioned that we might get a lightweight form of this in GHC. How can you talk about that? How does it differ from what you presented?
Come again?
You mentioned that we might get a lightweight form of this in
Oh
GHC.
yeah.
But
So
how
my-
does it look like? What can we expect?
So my student has looked at this, and from some very small modifications to the GHC, he's been able to kind of associate. Well, too bad Phil ain't here. Give me back that. What you can do, but of course it's not a whole lot, is you can get error messages like these. So the idea is that you can associate error messages like these inside the Haskell code where you make the definitions of your functions or where you use the functions. You can, so he made some kind of type level what's not called later. So it's of a different, some kind of different kind, and then you can, with that later, you can associate this error message. And later also kind of says, don't check this immediately, but wait a little bit. But actually, when it then finds out that particular constraint is to blame, it will, in addition to the GHC error message, also give that particular line of text. So this is really hacked into the GHC, but it's really lightweight. And you don't need, you just write this stuff in your own Haskell code. You don't need two separate files and everything because it's just in Haskell.
And it will always only be in addition to the traditional GHC error message.
It is only in addition to the GHC error message, and it's also checked for soundness.